to solve speed and acceleration problems. Okay, so let me get this up and running right here. So let's take a look at the very first problem that we have here. And I'm going to get my pen up and running, and we're going to look at a pen color. So we got red here, that's perfect. So basically I'm going to circle elements that are in this particular problem. An airplane flew 1,000 meters in 400, right there, 400 seconds. Okay, and we want to know the speed. So down here I'm going to write the formula for speed. Speed is equal to the distance divided by your time. Now, if you don't know this, we have a triangle drawn over here. And basically, when you see this particular setup on this triangle, when you see this line right here, the division line, I want you to think of this line as well as your division line. So that means D will go here, and then T will go here. That's our time. And then that leaves the third and final one as your speed. So what we're going to do is we're going to take the two numbers that I have up here and we're going to plug them into the triangle that we have here. So the 1,000 meters, M is meters, and that is a distance. So I'm going to plug this number in up here, 1,000, okay? And I'm going to write my unit down. It's a meter. Okay, and then we have 400 seconds, and second is your time. So then I'm going to write this down, 400, and I'm going to put my unit down, S for seconds. Now my division, or when I look at this particular problem, I'm going to divide because 1,000 is on top of 400. So when I take 1,000 and I'm going to divide it by 400, let's all do that calculation wise, okay? And let me get my calculator up and running. When you do 1,000 and I'm going to divide it by 400, I get 2.5. So let me write this over here to the side just to show. 1,000 divided by 400. My calculation, my speed would then be 2.5. And my unit for this one would be a meter per second. Okay? Any questions with that one? Okay, let's go to the next one. Now this one's problem number 6 on the worksheet. That other one that we did was problem number 1. Okay, so for this one right here, again, how long will it take for a ball to roll 26 meters if its speed is 2 meters per second? So when I look at that one again, let's look at our pen, set up our pen. Speed again is equal to distance divided by time. Okay, when I set this up, again, remember distance is up on top, so I'm going to put 26 right here, 26 meters, okay? And its speed, I know its speed, and speed is right here, so we're going to put the 2 meters per second, okay? Now, I'm solving on this one how long. Long is dealing with time. That's your time. Okay, so this is what we're actually solving for. Again, I see it right here. We're on top. So therefore, I've got my distance. Distance is on top. And I'm going to divide it by my speed. So 26 divided by 2 would actually be 13 on here. 26 divided by 2, take half of 26, I get 13, and my unit for that one would be a second. Okay, so it's a matter of plugging it in. All right, let's look at the next one. How far, so let me get my pen. How far. Far is dealing with distance. So we're going to solve on this one for our distance. Okay? And let me get this spelled out. Distance right here. All right, so how far will a horse trot with a speed of 4 meters per second? All right, so here's our speed down here. Remember the formula. Speed is equal to distance divided by time. Okay, so we have 4 meters per second. So we're going to put this right here. 4 meters per second. That's your speed. I'm going to write an S up here for speed. And we have, and I'm going to circle that. That's 4 meters per second. And we have 60 seconds, which is your time here. Time. Okay? So I'm going to write 60, and I'm going to write the unit S. Okay. So on here, we want the distance. The seconds are going to cancel out. So we know this one's going to be a meter up here for distance. So we're going to multiply this. 4 times 60 would be 240. So we're going to actually multiply. And my key thing is, if it's side by side, you multiply. Side by side, you multiply. Do it like this. Side by side, you multiply. If it is distance on top, you'd have to divide. But these two were given. So we're going to multiply. All right, any questions with speed? Okay, now we also have a graph, and we need to understand how to solve problems according with graphs. So this first one, this one's problem number 14, 15, and 16 on your worksheet. So let's look at this one. It says, what is the average speed of the first 50 seconds of a trip? So down here, time is on your horizontal axis right here. Time is in this one. And so 50 seconds is right here. Okay. And I go up, all the way up, followed all the way to the top, and then come across to find my distance. This one's distance right here. Okay. Now on here, to find the speed, you're going to take speed. Remember, speed is equal to distance divided by time. Now this line right here is your speed. Right here, this line right here is your speed. So to find your speed on here, you take 100 divided by 50. So it would be 100 divided by 50. And when I do that, 100 divided by 50, I get 2. And so my speed would be 2 meters per second. Okay? Now on this next one, they want to know what is the average speed of the first 70 seconds. So right here, so 70, right here, 70 seconds. And when you see average, it is a total distance divided by total time. So your total time at that point is 70 seconds. And then just follow it over. And so we traveled a total of about 40 meters. And so on there, again, that speed is equal to distance divided by time. Okay. And so I traveled 40 meters. Okay. 40 meters in 70 seconds. Okay, now taking your calculator out, because this doesn't come out nice and even. So then I'm going to take my calculator, and I'm going to take 40, and I'm going to divide it by 70, and I get 0.57. We'll just round it to the nearest tenth. 0.57. Or actually, that's 100ths place. It's rounded. If you want to round it to the nearest tenths, it would be 0.6. Okay? And on here, what is the average speed for the whole trip? Well, this whole trip right here traveled 100 seconds, and going up to the very top, it traveled 160 meters. So again, on there, we're going to take the 160 meters and we're going to divide it by 100. And when I divide those, I get 1.6 meters per second. And I didn't write this one. This one, the speed for that one would be a meter per second as well. Any questions? If you have any questions, be sure to see your teachers for that one. All right, now let's go to acceleration. So let me write the formula for acceleration. Your formula for acceleration is a change in velocity, which is your final velocity, minus your original or initial velocity. That's your starting. What you end with minus what you start with divided by your time. So when I set this up here, this right here also is your change in velocity. So I'm going to write this up at the top, that is your change in velocity. Change in velocity just means your final, again, minus the initial, okay? All right, this one right here is A for acceleration, goes right here. And then this one is your time for seconds. Okay, so on here we go from 0 to 24, okay? 24 minus 0, that's your final one there, in 3 seconds. So what I'm going to do is do the final is 24 minus 0. And 24 minus 0 is actually 24. Okay, so I'm going to circle that. So you find the difference between the two velocities, okay, or the two speeds, and you get 24. And all that occurred in 3 seconds. So I'm going to write 3 right here. And so to find how fast you moved, you would take 24 divided by 3, and you get 8. Now the unit for acceleration is a meter per second, and we're going to square it, okay? All right. Next one. On here, again, the acceleration, change in, whoops, let me go back to this one. Okay, let me get my pen. Okay, this one, again, change in the velocity, which is my final minus the initial. And then this one's your acceleration here, and this is your time. All right, so let's take a look. A car accelerates from a standstill. Now, if you're at a standstill, that means that I am at 0.
It's 2 o'clock.
Okay, so we're at 0, so it's 60 meters per second is your final. So you're going from 0 to 60 in 10 seconds. You've heard those with the car commercials, or a car driving from 0 to 60 in so many seconds. So on here, my final is 60. Okay, my initial is 0, so 60 minus 0 is 60. And this one is meters per second. I didn't write that on the other. Meter per second. Okay, now my time is 10 seconds, so I'm going to write 10 seconds down. Because it's on the top, we're going to divide. Remember, if it's on the top, we divide. So now we're going to do 60 divided by 10, and I get 6. And on there, the unit for acceleration is meters per second, and it's squared. Okay, meters per second squared is acceleration. A velocity unit is a meters per second, and your time is in seconds. Okay, let's go to this one right here. This is problem number 9 on the worksheet. All of these are identified by the numbers on the worksheet. Number 9 says a runner has accelerated at a rate of 11.1 meters per second squared for 9 seconds, and they want to know the change in velocity, or that final velocity. So let me get my pen. going. Okay, so remember, this is your change in the velocity. This is your acceleration, and this is your time. So the acceleration is at 11.1, and this is a meter per second, and it's squared. Okay, your time is 9 seconds, and if they're side by side, what did I say you do? Side by side, you multiply. Okay, side by side you multiply. So we're going to take our calculator and we're going to multiply 11.1 times 9, and you get 99.9, 99.9, and that change in velocity, a unit for velocity, is a meter per second. Okay? Now, what I would like for you to do in your groups is sit down and try to answer all those other questions, and your teacher will go over the answers with you. Thank you. Bye.